The next one is going to be kind of a puzzle for you to figure out. This is 111.asm. Let me put it in there. And let's talk about this one. This is a defective program, so I nano 111.asm. All right. First, let's compile it and see what it does. So I go back to this one and change this to 111. That does the compiling, and then I have to do linking in a separate step. All right, now I can run it. And the idea is you put in a number and it will triple that number. But as you can see, it doesn't seem to work at all. Now, I can also put in letters and it will try to change those into things, so we can try to figure out what's going on here. So let's look at the code here. Now it's reading. 3 is sysread, so it will read for link the buffer in from buffer in. Down here we have some variables. There's an input buffer that has maybe 3 or 4 spaces, and then a character return line feed, and then it has length here, so it can read that many characters. So I can put in a few characters and it'll read them. Here's the buffer for out for printing. So it will read something from the user, then it will try to double it by taking the single byte, the lowest order byte from buff in, and then shifting it to the left by 1. Now that should double it. If it was a number, moving left by 1 will double it in binary, and then adding the original one to that. That would triple it. You double it and then add 1 more, then you just put it in buff out. So that's then down here, it's going to just print buff out. But as you can see, it doesn't work. And the reason it doesn't work, of course, is because the code, the data you put in there is read as ASCII. And we should be able to see this. In fact, this is a good time to practice using the debugger. For some reason, it doesn't work. So the GNU debugger is how you handle it. So let's see if we can GNU debug this thing. I go in here. There's a start there. I can disassemble at the start. It'll show me the code. That's all the code. There's not really much to this program. And now I can put breakpoints in. So here, for example, is the int 80 that reads from the user. And by the way, I can do info proc mapping to see the data sections. Oh, I have to run. Okay, so what I'm going to do is I'm going to put a breakpoint after it reads data. And here's where it does the shift left. This is where it tries to double something. I'm going to break at that point, which is start plus 27. So I break at start plus 27. All right, now I can run it. It'll run to that point and then stop. So I run it. I'm going to put in a 0, enter, and now I get to the breakpoint. Now, here I can now examine info proc mapping. I can see these sections. This is the code section, and this is the data section at this address. I can examine the data there. So I can examine, say, 12 hexadecimal words at that address. All right, so here you see space 0A30. Now what this is, you have to read it backwards. This is a little endian. So the 30 is the 0 I typed in. 30 is the ASCII code for 0. So this is the fundamental problem. When you type in a number, it did not read the number as a decimal number. It read it as a character. So it took the 30, which is the ASCII code for 0, and it's going to triple that, turning it into 90, which is no longer a printable character, which is why nothing is working. So if I used a space, which is 20, I should get a better answer. So let's get out of here. And if I run this program and put in a space, enter, now I thought I would get something printable, but I'm not. Anyway, the point is that's the problem. So what you have to do is you have to turn the input from a ASCII code back into a number. So the logical thing to do, and this is a fundamental problem with C and really with the hardware, is the same byte could be interpreted as an integer or as an ASCII code. Now I know the sysread interpreted as an ASCII code. What I really should do is subtract 30 from it, because in digits, 30 in hex is the 0, 31 is 1, 32 is 2. And let me bring that up. If you don't know your ASCII, just Google ASCII table. And you'll see there's tons of them everywhere. Here's 30. In hexadecimal, 30 is 0, 31 is 1, 32 is 2. And 30 itself is 48. So if I want to improve this program, there's one immediate improvement I can make. I can go here, and after I read it in, here I'm going to start within an A left. Now what I'm going to do is subtract from A left 48. Then I'm going to triple it, and that's going to make the number triple, and then here I'm going to add the 48 back in to print it in ASCII. So this should work for small numbers like 1, 2, and 3. If I add A left 48 there, that should turn it from an ASCII code into a number, and then you triple the number, and then you turn it back to an ASCII code. So this might work better. Let's see if that works. I compile this. All right, now I run triple. All right, if you give it a 1, I get a 4. Well, that's pretty good. Now I got 4 times instead of 3 times, but it's a lot better. If I give it a 2, I get 8. So I missed by a little bit somehow, but I'm getting there. That's what I wanted to show you, is a few tricks you can use. And let me see if there's anything more to mention about this project. So one thing I did here was I printed things out inside the program. Instead of using the debugger, this is another way to do it. You can just print everything that comes in. Every time you do something with A left, print it out, make a print C routine that'll print it out, and then you'll see after every step what it does, and you can figure out why it's going wrong. So that's another way to do it. And so I've got some challenges here that you can do based on that sort of stuff. So I'm going to stop this recording.